So today we'll be looking at Chapter 17 in your Introduction to Networks course. So Chapter 17 is really just pulling together every single thing that you've done for the semester. And we're just going to look at the first part of that, and I'll do another video for the second part. So what we're going to be looking at it's called Building a Small Network. So we're going to be looking at these different objectives here in the next few minutes. So let's go ahead and get started. So at the beginning of the semester, we looked at different types of topologies. And if you'll remember, there's various types of topologies. There's a physical topology and there's a logical topology. Your logical topology would be referring to your IP addressing scheme, whereas your physical topology would be the way your devices are physically connected together. And there is a difference between small networks and larger networks. So the first part of this chapter is looking at small networks. Some of the device considerations that you may have when selecting things for a small network. Now, again, I'm not going to read all of this to you. I'm just going to kind of give you an overview. You should probably read through and look at this a little bit more in depth. But I just kind of wanted to point you in the right direction. So one of the things that you need to consider when you're wanting to purchase things for a small network, number one, obviously, would be cost. That would definitely be an issue. But you want to make sure you compare apples to apples when you're looking at the cost. So, for example, look at things like your speed. Okay, what kind of speed are you getting? How many ports or what types of ports are you going to have on the different devices that you're getting? Because you could be looking at the price, and if you're not comparing apples to apples, as I mentioned a few minutes ago, then each one of the devices could have different types of ports, for example. Or if you have different types of interfaces, look at how expandable the devices are. Like, could you actually add another wick to a device and extend the life of that device a little bit longer? Also, your operating system. So there's different features, different services with your various operating systems. So some support these services that you see here and some do not. So again, check that. When you're considering your IP addressing, if you're looking at your scheme, you need to think about what devices are going to receive IP addresses. End user devices, servers, other peripheral devices, intermediary devices. All of those would need IP addresses, and you want to think about the scheme. You want to think about how you're going to kind of logically group those together. Okay, because that will definitely make a difference in the type of addressing scheme you have. You may think about if you needed to use a private address inside your network. We talked about using private addresses within your network and then having to use NAT to translate later. So those are all design things you want to think about within a network, as well as redundancy. So here you see some redundancy built into the network. So you have more than one switch or redundant servers. Also, look at all the cabling involved here. So you have redundant cabling. In case there's a link failure in one area, it can use another. You may also have routers that are redundant within a network. Traffic management is also something you want to take into consideration. So why would we consider traffic management? Remember your quality of service in prioritizing your traffic. So if you look at this diagram here, you see higher priority items and lower priority items. Now those items that are on the lower priority are things like FTP, or it could be email. Those are listed as a lower priority because the higher priority items are usually going to be used for things like streaming. Now, why would you prioritize streaming, such as voice or video, over email. Yeah, email is important, but if there's a lag in your network, you're not going to notice that you get an email a few seconds later. However, you will notice a few seconds of delay within a video or voice. So that's why streaming services generally will be provided a higher priority. And you can set that up within your network. Okay, you can give some things higher priority than others. Now, so far as your applications within your network, okay, it's important to understand that some applications are network applications and some are application layer, as in specific to that computer. A lot of times your users don't know the difference either, so that would be a question if you're in tech support and someone calls you over to their computer or calls the helpline and says they have a particular problem. Okay, they can't communicate. Well, when you start asking questions, you could find out that it could be on that particular device at the application layer, or it could be network. So obviously things like your email clients and connecting to a website would be more network related. But then you're going to find that there are some protocols and some applications that people are using that are actually on that device itself. If you want to look at what's actually running on your device, you can go to Task Manager, so you'll see a description of this. And you can see the resources that those particular applications are using. So if one's using more than another, then you would see that here. Or if they're running an application that's really, just eating up the resources, you would see that listed. Now, there are various protocols that help support all the applications and different services that are being used. And some of those are remote access protocols, such as Telnet and SSH. Now, so far you've used Telnet. You may not have used SSH. The main difference is that SSH is more secure. Okay, secure shell protocol. So it's more secure than Telnet. Okay, it will automatically do the encryption, and it may ask for keys, whereas Telnet is actually plain text. You can go in and encrypt those passwords, but by default that does not happen. So secure shell is the preferred method for remote access. But in this class, you're taught the Telnet method. Now, when they're referring to SSH-enabled devices, you'll see those terms network device and server. So the server is going to provide support to the various clients, and the other network devices would be your routers and switches and other access points. Now, there's various types of servers within a network. If you're a really small, like mom and pop organization, you may have all of those services on one server. However, if you're a larger organization, you may have those divided. So that, for example, we see here you have a web server. So it handles all the web requests, all the web pages. Email handles all the email. So that's where the SMTP protocol would be used, or the POP3 protocol or IMAP. You may have FTP, just for transferring files. You may have a large number of files that people need to use within your network, so you may have an FTP server. There could be a DHCP server, which just handles all the DHCP processes. And in addition to just receiving an IP address, there's a lot more information that can be handed out via the DHCP process. And then DNS. So if you remember, your DNS resolves your domain name to an IP address so that you don't have to remember. For example, the Cisco.com website is actually this address here, the 72.163.4.185. It actually does keep a table of that. Okay, so here we're looking at voice and video applications. There's a lot more of those out here now than what used to be. Now, your network infrastructure has to support all the real-time applications, and that's probably something from an IT standpoint that you'll constantly be examining and looking at upgrading, because there are new technologies that are out all the time. So you'll want to make sure that your cabling, that your operating systems can handle it. Okay. Whenever newer products come out, or you're going to actually need to transition over to those, so you'll need to look at all of that. And that will really affect all of your, what we call your real-time applications, especially those that stream. So your voice over IP, because I think that's what everyone is using now, is your voice over IP network, which definitely relies heavily on all your network infrastructure. Your real-time applications, there's lots of protocols that can be used for real-time, and a lot of those network devices that support your real-time applications also support your quality of control that I was referring to earlier, where it's prioritizing some traffic over others. So when you have a smaller network and you were thinking about all those considerations that I've already mentioned, another thing you must think about is how you're going to grow your network, because obviously you're hoping your network grows. And I mean, nobody builds a business or works anywhere where you hope it stays exactly the same. So when your network is growing, or we're referring to the scalability of a network, there are several things that are required, such as network documentation. Well, what's your network documentation? Your physical and logical topologies. And those are important because you want to be able to have things in place so that you can quickly go to, say, a map of your network. If you're sending someone to a certain room to go repair a device or go look because something's happened to the network, it's easier to look at a diagram and tell someone exactly where to go to fix that device or repair whatever issues that they're having. You want to have a topology for the logical aspects. Your logical topology refers to your IP addresses. So if there's an issue on your network, say you're using Wireshark and you're looking and one particular device is eating up all your bandwidth, well, you can find out where that device is. Okay. You also want to have a device inventory. Know what devices you have on your network. So those two things are important, not only for the purposes of the current people using the network, but how about if someone leaves, for example? Someone takes a job somewhere else. You want someone to be able to step in and kind of know where the last person left off. You don't want one person having all the knowledge on a network, because if they leave for whatever reason, it could really put the other people in a difficult situation with having to figure all this stuff out. So ideally, you want all this stuff written down somewhere so that somebody could look at it and be able to kind of pick up from where the last person left off. In order to scale a network well, too, one of the things that would be important would be your budget. A lot of people don't think about that when you go into IT. You don't think about managing a budget, but there's a whole lot of justification that goes involved with asking for new equipment. So you definitely want to be aware of whatever the budget is and looking at the fiscal year and seeing what the needs are currently of your network and moving forward as well. Traffic analysis is very important. So far as your documentation that I was referring to earlier, really you want to have traffic analysis included in that. So that would be using something like Wireshark. Wireshark not only manages your traffic, but one of the important things that it can do is, so you're looking at this here, is it can give you a good baseline of your network. So why do you want a baseline? Well, a baseline is very good for seeing how your network performs on a normal day. So this would be like you going to the doctor whenever you have a 1-year appointment every year to just see what your blood pressure is like, on a normal day, what your blood sugar is like. So that way, when you're sick, you have something to compare it to when you're healthy, and see kind of what might be the issues or the target areas you might want to look at. Same way within a network. You want to develop a baseline and do that, say, over a week time period. You can use things like Wireshark, or you can use some other protocol analyzers and see if there's peak times of the day that you have certain network applications being used, or a certain number of users on, or if you're uploading some backups to a server somewhere, so that you know that ahead of time. That way you're not caught off guard when your traffic pattern changes or your bandwidth utilization goes sky high, because you know that normally on Thursday at 4 o'clock, that's when HR sends a backup to the network. Okay. Which brings me to the next point, is the employee network utilization. So there are lots of ways you can gather like a little snapshot of information. Okay. So you see some things you might want to grab a snapshot of. Your operating system, the versions, the CPU utilization, your RAM and your drives, some of your non-network applications, as well as your network applications. So it might be a good idea to see over a period of time what your users are actually using and how you're using the network, so that you can be prepared. You can see the step-by-step to go through and actually look at that usage, going to your settings and network and internet data usage and network interface. And it should show you, this data usage tool should show you from the last 30 days, I believe. So you can see what's used most often. Now, when you're doing some troubleshooting, there's some basic tools, and you've used these already this semester. So make sure you're comfortable with those. Not only will you use them in this class, but they're going to be your basic tools that you're going to use if you're going into IT and you're starting with your troubleshooting. This is where you'll start at. So you'll issue a ping, and I would usually recommend issuing a ping. You might want to ping the loopback, which is that particular device. And then you'll want to ping your default gateway. In this case, it would be this router. And then you'll go a step further and ping another device. So when you're looking at the output of that ping, there's some important things you'll want to look at. How many packets were sent? How many were received? Look at the amount of round trip time. Also, look at where your reply is coming from. A lot of people leave that out. So if they're pinging 10.1.1.10, okay, the reply is coming from that device. But there might be cases where your network is down, your computer is not connected to the network, and you issue a ping from a remote device, and you'll see the ping coming from your device, which means you're not leaving your device. That will help you kind of isolate where your issue is. And you'll find out that, well, that ping didn't even leave your device. Okay. These are your ping indicators, so make sure that you know what these all represent. Ideally you want to see your exclamation points. Your periods and your U's are not what you want to see. I'm not sure that we've done an extended ping yet, but this is also another option. Whereas ping sends that message from that particular device, the extended ping can actually be used to send a ping from a different device. For example, we have the command here. Normally you would type ping space and 10.1.1.10 or ping space 192.168.10.1. Well, what they're actually doing here is they're in R1, but they're sending the ping from a different device. So they're in R1 and sending the ping, I believe, from PCB. So you can send it from a different device. And the source is going to that 192.168.10.1. Now, if you issue a ping and it's not successful, one thing you can do is follow that up with a trace route. So the trace route will show you exactly what devices that message is going through, so that you know, well, it passed through the 10.1, but it timed out after that. So it's just not getting any further than that device. Okay. You can do this on a Cisco device. You can also issue ping and traceroute commands from PCs as well. You can also do an extended traceroute, just like you did an extended ping. Now, I mentioned earlier, using a network baseline, ping and traceroute can be used to help with that network baseline when you're collecting that information to see how a network typically functions. And you can use the amount of time that a ping is sent, okay, the amount of time it took for it to return, and then compare that time also and include that in your network baseline information. You do have a lab on testing network latency, latency meaning delay. So testing your network latency with ping and traceroute. And I would suggest that you do that. And this ends the part 1 of chapter 17.